you have 8 coins in a bag. 3 of them are unfair in that they have a 60% chance of coming up heads when flipped. The rest are fair coins. So if 3 are unfair, the rest are 8 coins. And when I say that, or when this problem says that they are fair coins, it means that they have a 50-50 chance of coming up either heads or tails. You randomly choose 1 coin from the bag and flip it 2 times. What is the percent probability of getting 2 heads? So this is an interesting question, but if we break it down, essentially with a decision tree, it'll help break it down a little bit better. So let's say that, so we have a bag. 3 of them are unfair. So we could even visualize the bag. You don't have to do this all the time. So we have, I'll do the fair coins in white. 1, 2, 3, 4, 5 fair coins, and we have 3 unfair coins. 1, 2, 3. And this whole thing is my bag right over here. That is my bag of coins. If I were to, when I take my hand in, if I were to take any of these white coins, there's a 50% chance that it gets heads on any flip. The odds of getting 2 heads in a row would be 50% times 50% for these white coins. But I don't know I'm going to get a white coin. If I get one of these orange coins, I have a 60% chance of coming up heads. And the odds of coming up 60%, if I have picked one of these orange coins, the probability of getting heads twice is going to be 60% times 60%. So how do I factor in this idea that I don't know if I've picked a white fair coin or an orange unfair coin? And we'll assume that the coins actually aren't white and orange. They all look like regular coins. So what I'll do is I'll draw a little bit of a decision tree here. I guess maybe I could call it a probability tree. So there's some probability that I pick a fair coin. And there's some probability that I pick an unfair coin. And so what is the probability that I pick a fair coin? Well, 1, 2, 3, 4, 5 out of the total 8 coins are fair. So there is a 5/8 probability. There is a 5/8. I'll write it here on the branch, actually. So there's a 5/8 chance that I pick a fair coin. And then there is a 1, 2, 3 out of 8 chance that I pick an unfair coin. So if I were to just tell you what's the probability of picking a fair coin, you'd say, oh, 5/8. What's the probability of an unfair coin? 3/8. And you could convert that to a decimal or a percentage or whatever you'd like. Now, given that I have picked a fair coin, what is the probability that I will get heads twice? So let me write it this way. And this is just notation right here. So the probability of, I'll call it heads, heads. So I get 2 heads in a row, given that I have a fair coin. It looks like very fancy notation, but it's just like, look, if you knew for a fact that that coin you had is absolutely fair, that it has a 50% chance of coming up heads, what is the probability of getting 2 heads in a row? Well, then we can just say, well, that's just going to be 50%. So 50% times 50% times 50%, which is equal to 25%, which is equal to 25%. Now, what is the probability that so if you want to know what is the probability that you picked a fair coin and you got 2 heads in a row? So given that you have a fair coin, it's a 25% chance that you have 2 heads in a row. But the probability of picking a fair coin and then given the fair coin getting 2 heads in a row will be the 5/8 times the 25%. So the probability, so this whole branch, I should maybe draw it this way. The probability of this whole series of events of happening, so starting with you picking the fair coin and then getting 2 heads in a row, will be, I'll write it this way. It will be 5/8, 5/8, times this right over here, times the 0.25. Times the 0.25. I want to make it very clear. The 0.25 is the probability of getting 2 heads in a row, given that you knew that you got a fair coin. But the probability of this whole series of events happening, you would have to multiply this times the probability that you actually got a fair coin. So another way of thinking about it is this is the probability. This is the probability that you got a fair coin, and that you have 2 heads in a row. Now let's do the same thing for the unfair coin. So the probability I'll do that in the same green color. The probability that I get heads, heads, given that my coin is unfair. Given that is unfair. So if you were to somehow know that your coin is unfair, what is the probability of getting two heads in a row? Well, in this unfair coin, it has a 60% chance of coming up heads. So it will be equal to 0.6 times 0.6, which is 0.36. So if you have an unfair coin, if you know for a fact that you have an unfair coin, if that is a given, you have a 36% chance of getting two heads in a row. Now, if you want to know the probability of this whole series of events, the probability that you picked an unfair coin and you get two heads in a row. So the probability of unfair, and two heads in a row, given that you had that unfair coin, you would multiply this 3/8 times the 0.36. So this will be equal to the 3/8, this 3/8 times 0.36. And so let's get a calculator out and calculate these. So if I take 5 divided by 8, 5 divided by 8 times 0.25, I get 15 point, or I'll just write it as a decimal, 0.15625. So this is equal to 0.15625. And then if I do the other part, so if I have 3 divided by 8 times 0.36, that gives me 0.135. So this is 0.135. So if someone were to ask you, what's the probability of getting of picking the fair coin and then getting two heads in a row with that fair coin, you would get this number. If someone were to say, what's the probability of you pick the unfair coin and then get two heads in a row with that unfair coin, you would get this number. Now, if someone were to say either way, what's the probability of getting two heads in a row? Because that's what they're asking us here. What is the probability of getting two heads? So we could get it through this method, by chance picking the fair coin, or through this method, by chance picking the unfair coin. So since we can do it either way, we can sum up the probabilities. Either of these events meet our constraints. So we can just add these two things up. So let's do that. So we can add 0.135 plus 0.15625 gives us 0.29125. So 0.29125. That's when we add 0.15625 plus 0.135 will equal this. And if we want to write it as a percentage, you essentially just multiply this times 100 and add the percentage sign there. So this is equal to 29.125%, or if we were to round to the nearest hundredths, then this would be, well, this would be the exact number, or we could say it's approximately 29.13%, depending on how much we need to round it. So we have a little less than a third chance of this happening. And the reason why, remember, if it was a fair coin, there would only be, if everything in the bag was a fair coin, there'd be a 25% chance of this happening. Because you would just say, OK, any of these, they're all the same. Flip it twice, 25% chance. Our chance is a little bit higher because there's some probability, there's a 3/8 chance that we pick a coin that has a higher than even chance of coming up heads.